Hi class. So what we're going to look at now are Diels-Alder reactions. And what Diels-Alder's reactions do is take dienes, so you can see our diene, because remember the die means two and ene means double bond, so we have our conjugated diene on the left, and react it with a dienophile. So it's similar to electrophile. This is going to be a double bond that accepts electrons. Right? Now the nice thing about this is it's a flow of electrons. So these electrons are going to hit this carbon, these electrons are going to push in here, and then these electrons are going to push out and hit this bottom carbon. So what I like to do is, we know that for a Diels-Alder reaction, we're always going to make a 6-membered ring. And so we can just number around, so it's 1, 2, 3, 4, 5, 6. So if we come over to our other side in our product, we can just draw our 6-membered ring. And then let's just number them the same way. So we start on the top as 1, 2, and we'll just go all the way around. And the reason I like to do this is you can see where things should branch off of the ring. So for example, let's look over here. Off carbon 2, there's a methyl group, and off carbon 3, there's a methyl group. So we come over to our product. Off carbon 2, we need a methyl group, and off carbon 3, we need a methyl group. And also, let me point out one other thing, that this double bond, this arrow tells us we're moving it over one, so we're actually making a double bond between 2 and 3 and losing this one. So let's put that in. And there's our double bond. And now, if you look at these arrows, so this arrow is telling us we're making a bond between carbon 1 and 6. So that's here. This arrow tells us we're making this bond between 4 and 5. So we've done that. And that's why we don't have a double bond between 1 and 2 and 3 and 4. Because those pair of electrons went to make these new bonds right here. Now, off carbon 6 though, we do have these electrons that get pushed out over, and then now we have a carbon group coming out to make the carbonyl. And it was an aldehyde, so it stays an aldehyde. Right. So this is really important because now we can see that that group stayed here. We kept our 2 methyl groups. These are the 2 new bonds we made, and here's our 6-membered ring. Alright, let's try another one. Same idea, and this time, I'm just going to redraw it just to make it a little bit easier to see. We'll keep the product, or the starting material, on the left exactly the same, because it's in a pretty good shape. The other one's a little bit crooked, and I think if we just change it, it'll make it a little bit easier to see. Alright, because now what we can do is we could show that our 6-membered ring is going to go from these carbons here. And so our 6-membered ring is going to be around these 6 carbons. 5, and then 6. Alright, so let's just do that to start. Let's draw our 6-membered ring. Alright, now what's unique about this one is, do you see how there's this carbon here in the middle? It's not part of our 6-membered ring. It's kind of in the middle, right? It goes from 1 up and then connects to 4. So let's number over here really quick just to kind of show where everything's at. And so what this one says is it's going to go from 1 to 4. And this little apex is sitting right here in the middle, was this one. Alright, now, off carbon 6 we have a ketone, so let's draw that. Off carbon 5 we have a ketone, so let's draw that. Alright, and then lastly, if you remember, let's push all these electrons around. So these are going to go up, down, and over. And so what this electron here is saying, we're going to take this pair of electrons, push them out here, and make this bond. These electrons are going to push down. Right, so when they push down, they make the double bond here. So we need the double bond between 2 and 3. And then these push out, so they make this bond here. And that's this one. Alright, now one thing I do want to say is, do you see how over here these are cis? Alright, so because they're coming off the same side of the double bond, they will stay cis in our product. Alright, meaning they're both either going to be wedged or they're both going to be dashed. And then the same, if those are pointing down, this will point the opposite direction. Alright, so this will be folded up. And remember, the Indo product is the we can make the Indo or Exo product. Let's try one more. So now on this one, the same, I've redrawn it, just so it'll be easier to see where we're going to make the bonds between. Alright, so we're going to make this new bond and this new bond here. And the way it's going to work is we're going to push these electrons over, push these down, and push these over. Alright, and what that gives us is a 6-membered ring. Now, the same as before, I think numbering really does help. I know it's a little bit tedious, but it does make things run a little bit smoother. Alright, so we got our 6 carbons. So let's do the same here. Same as before, if you look at the top one, so this carbon here, this is this carbon, so going off of that one we have our ketone again. And now the thing I want to point out is we've got a triple bond, so we use one pi bond to make this new bond, right, which is between carbon 1 and 6, but since we have a triple bond, we actually have a double bond left behind because we only use one pi bond. Alright, the same as before, we get a double bond between 2 and 3. The 2 methyl groups are still there. And now we get our product. Let me show you one more thing that I'd like to point out. So, remember you can explain how things are going to add based on resonance. So, let me draw a resonance structure and then we can come back and talk about it. So, if we have